Center's radio Zoom classes. This is SVN3E, grade 11 workplace science, and I'm the teacher, Bronwyn Slade. If you would like to participate live, you can call the Wahsa studio at 1-800-465-7144 or 737-4017. You can listen on the radio at 91.9 FM and on the television at Bell Express View channel 972. You're always welcome to join me live through the Zoom link, which is available from me, your teacher, and also your DEC. Our classes are scheduled Monday through Thursday from 10 until 11 in the morning, and we are in our 5th week of our 9-week course. As we are about halfway through our timeline, at this point you should be submitting work for marking. A reminder that the key questions are marked with a little key icon and are listed at each of the aisle at the end of each of the aisle lessons. So you need to do all of these questions and hand them in. Some of them are check your understanding questions, some of them are activities, and some of them are review questions. Explain your ideas and thoughts in complete sentences and make sure you're actually answering the question. But you can do this either by hand or electronically. If you want to, you can write in your workbook and make notes. However, the end of where the questions are on the review pages are quite small area. So I would strongly encourage you to answer your questions on a separate sheet of paper in order to give yourself space to give full ideas. If you're going to do it electronically, PDF, Word, and Google Doc files are the easiest for us to open. Here at Wahsa, everyone has access to Google Doc files through your NNEC email address. We're happy to support you to figure out how to do that if you need to learn. If you need to use a different kind of file type, most likely just fine. Just let us know so that we can figure it out to make sure we can open them. Okay, so then how do you submit your work for marking? There's 3 methods. The first is to send your work in electronically. You can scan your work and through a device. If you have an Apple device, the Notes app has a scan function. And if you have an Android device, the Google Drive app has a scan function. So feel free to use either of those. If you need to just take pictures because you can't scan, that's fine. Scanning just makes the file slightly smaller and easier for us to manage. Then send it to us through email at studentwork@nnec.on.ca. There has been a change and I am no longer marking for this class. I am instructing for the remainder of this term, but not marking. So connect with John to send your work to him if you're going to email it. His email address is jstradiotto@nnec.on.ca. If you're going to drop it off, the second option is to drop it off in Sioux Lookout. We have an outdoor mailbox at our 74 Front Street location. We're the bright red building next to the post office, and we have a small white mailbox next to our side entrance. So you can just put your work in there at any point and we'll get it back to you as soon as we can. We're not yet open to the public, but hopefully soon. The third method is to hand your work into your DEC. Your DEC can either send your work through the Express or fax it to 807-737-1732 or toll-free fax to 1-800-463-7852. Students are also welcome to send their work by fax if you have access to a fax machine. So even though I'm not marking, you're still welcome to connect with me through social media. And also all of our lessons are still being recorded and I'm uploading them to my YouTube channel in a playlist called SVN3E. So my Facebook and my YouTube channel are both under the name B Slay Wahsa. So feel free to still connect with me there if you have any questions or you want to talk about any of our lessons. Also remember that science is a really visual subject. I incorporate as many videos, diagrams, charts, illustrations as I can, just to really help us understand fully what it is that we're talking about. So accessing the full experience means accessing the visual part, the videos, as well as just listening through the audio. If you can't join me live through Zoom and you can't watch the YouTube videos, you don't have reliable internet, that doesn't work for you, that's fine. Just let me know and we can send you a copy of the videos so that you get the full experience and really set yourself up for success. All right, so if you have any questions or concerns, please reach out to us here at Wahsa. Again, I am the course instructor for term 1A. So for the next few weeks. After that, once we get into term 1B, then John is responsible for the course entirely, but my videos will still be up on YouTube. You can still totally access them. That is fine. If you want to reach out to me, connect with me through email. You can email me at bronwyn.slate@nnec.on.ca, or you can connect with me through Facebook at bslatewasa. You can call both of us at the office at 807-737-1488 or toll free at 1-800-667-3703. My extension is 2209 if you want to talk to me. If you want to talk to John about something that in terms of marking, his extension is 2210. And his email address is jstradiottto@nnec.on.ca. And his name again is John. He is the marker. Right, it's still super important to me to position myself in the context of this course, as it does structure how, or it not just doesn't structure how, it impacts how I teach. My positionality is such that I have white settler ancestry, and this means I have white privilege. My experience of education has been easier. I've had less barriers, and the system is set up for me to succeed as a white person. So this means that sometimes it's hard for me to understand the experiences of people who are not white. From people from the global majority, I don't understand in the same way. I try, but as a white person, I never truly will understand the barriers and the difficulties that other folks face because of white supremacy and white privilege. I do, however, live in Northwestern Ontario on the traditional territories of the Anishinaabe people, and this I am working constantly to learn and respect the culture around me and integrate those teachings that I can and the understandings that I can into our course. This is a lifelong journey and something that will take time, as I have lots to learn, as well as unlearn about our education system and about the ways we perceive knowledge. So it's a process. If anyone has any insights, resources, recommendations, suggestions that they'd like to share with me, if you'd like to do that labor, I welcome it, though of course understand that that is not your responsibility. Our textbook also is Eurocentric. It is based, from what I can tell, on the experiences of white people, and it centers the white experience and white communities, white scientists as the ideal, the ultimate, the only source of knowledge and perspectives. It ignores Indigenous, Inuit, Métis knowledges and experiences, and this, of course, is highly problematic and unfortunate or disappointing, really. I haven't been able to find another resource, and once I am no longer teaching this course, that will not be within my scope of change that I will be able to create. I do continue to work to integrate the knowledges that I have access to and the experiences that I know of Indigenous, Inuit, and Métis peoples into our course material in order to make that connection and start the process of making the course less problematic and more representative of the people who live in this country. All right, we are starting Unit 4 today. And Unit 4 is called Using Energy in Our Lives. So to give us a little bit of context, imagine an area as big as 50 football fields covered in solar panels. Over the course of 20 years, this sun field has enough energy generating panels to make sure that almost 152,000 tons of carbon dioxide are not pumped into the atmosphere by coal power plants. It is the equivalent of removing 33,000 cars from the road. So changes can be made about how we use energy, and there's benefits and interesting things to consider about all of them. So in this chapter, we're going to learn about renewable and non-renewable energy sources and the costs and benefits of each. So we are looking at lesson 13 today, where we're just going to start focusing on understanding what non-renewable and renewable energy sources are. At the end of this lesson, our sole learning goal is that you will be able to describe several non-renewable and renewable energy sources. You know that you've met this learning goal because you can explain why coal, crude oil, natural gas, and nuclear power are all non-renewable energy sources. And you can explain how hydroelectric, solar, wind, tidal, geothermal, biomass, and hydrogen fuel all create renewable energy. So we rely on non-renewable energy sources to meet most of our energy needs in our homes, our businesses, and our schools, but non-renewable energy sources cannot be made or renewed. That's why we call them non-renewable. We are starting to use more and more renewable energy sources because one day we will use up the non-renewable sources and they also harm the environment. So first we need to understand what is energy. So we're going to watch a little bit of a video that just talks about what energy is to help us understand what we're talking about when we're talking about renewable and non-renewable sources of energy. All right, so let's see.
Oh, Spiky looks tired. Let's give him something to eat. He seems to be fresh and active now. Do you know why Spiky was feeling dull before he ate the chocolate? This is because he had low energy. We need energy to work, and this energy comes from the food we eat. Energy is the ability of a body to work. There are various forms of energy. Some forms are heat energy, light energy, chemical energy, nuclear energy, electrical energy, sound energy, wind energy, kinetic energy, potential energy, and mechanical energy. Let's identify different forms of energy around us. A family is going on a picnic. It's a sunny day. The sun provides us with two different forms of energy. Can you guess what these are? Heat and light energy. Energy from the sun is called solar energy. Plants use solar energy for photosynthesis. The family is going to the park in a car. How does a car move? It moves because of the chemical energy stored in fuel. In the park, everyone's set up for the picnic while children are playing. Energy is also used to help things move. This energy is called kinetic energy. Now they're sitting at the table. Even sitting down requires energy. The energy of a body when it is at rest is known as potential energy. Now they're listening to some cool music on the radio. It runs on electrical energy from the battery. What kind of energy is the radio producing? Sound energy. Sound energy is produced when an object vibrates and disturbs the air particles near it. Thus, the energy of a vibrating body spreads out in the form of waves. When these waves enter our ear, we can hear the sound. The kids are playing on the swings. How does the swing move? The swing moves using mechanical energy. Mechanical energy is the energy possessed by a body due to both motion and position. Uncle is making a fire in the grill to cook food. What kind of energy is Uncle using to cook the food? He's using fire, which gives us heat energy. Heat cooks our food. It is produced when the particles of a substance start to move faster and faster and start to collide with each other. Look, a kid is flying a kite. How is the kite held up in the sky? By wind energy. Moving air is called wind. What kind of energy can we find in other things or people that were not doing anything? such as grandma sitting on her wheelchair and the trees in the park or uncle's grill. Do you think they have no energy because they were not moving? Do you remember what kind of energy a body has based on its position? Potential energy is stored in a body which is at rest. Let's summarize. Energy is the ability of a body to work. There are various forms of energy. Some of them are heat energy, light energy, electrical energy, chemical energy, sound energy, mechanical energy, potential energy, kinetic energy, and nuclear energy.
All right, so I know that that video is a little cheesy. I get it, but it just really covers all the different types of energy.
To make sure that we know when we're talking about energy, we're talking about renewable and non-renewable sources of energy, we know some of what that actually means. All right, so let's dive in. What is non-renewable sources of energy? So coal is the first one we're going to talk about. And coal is the most plentiful fossil fuel on Earth. It is removed from the ground using either surface mining or underground mining. In surface mining is used when coal is buried less than 70 meters underground. The topsoil and layers of rock are removed and to expose the large beds of coal beneath. Underground mining removes coal buried deep underground. So here is a diagram that shows us the two different kinds of mining that we do for coal. So here on the left, we have underground mining methods. So you can see where we have the coal is deep under the ground. We don't have a scale, so we don't know exactly how deep, but we have a slope mines where they go in and then pull out the coal from the coal bed. This black part is coal bed, where we have a coal elevator and a minor elevator, a shaft mine where you go straight down and you need an elevator. Then you go and you dig out the coal and send it back up in an elevator, and the people go back up. The miners go back up in another elevator. As you can see, you can't just take out all the coal because you need to leave something that holds up the ground. So that's just something to note. But you're really deep underground, which is why coal accidents and mining accidents are so detrimental, because you're going deep into the ground. Surface mining here on the right, you can see this orange line, dotted line here is the original land surface. So this is how the land used to go in terms of this hill. And then you can see that these machines have dug out to access these various coal beds. The rock spoil valley fill and the rock spoil here these are all the rocks that are being thrown away based on they're not coal, but they need to be, the ground has been dug away. So there's various different types of mining that happens in surface mining. We don't need to understand what all the different are, but just you can see that there's various different tools and ways of accessing these coal beds. Here is a picture that shows you some surface mining, right? You can see you can assume how this land used to be and how it's been dug away and changed. This, if you look at this is a truck. Just how huge, this is a huge truck. This is the wheel size. So think about, this is a ginormous truck. So think about how big this area is that has been scraped away to access the coal. And that would be a surface mining method. The underground mining method, here's an image where you can see there's a big auger, there's a big thing that's drilling into the ground to collect the coal, and these people are deep underground with headlamps on and different machines to access that coal. So about 20% of Canada's electricity is fueled by coal. We're going to talk a little bit later about how electricity works. Once the coal is separated from rocks, dirt, and other unwanted materials, it is transported to electric units, companies, and their other industries. Power plants burn coal to make high pressured steam. So this is how coal creates electricity. They burn it, they release the energy that is the potential energy, the energy that is stored in the fuel. So it's chemical energy that then creates high pressured steam. The force of the steam is then used to rotate blades on engines called turbines. So the steam pushes the turbines, the blades, and that then we have movement. And then the mechanical energy of the spinning blades, the movement of the spinning blades, is then converted into electricity by generators. So that's how coal becomes electricity. So here is a diagram that you can see. The coal has been mined and then brought and is put into this factory. And here the coal comes in on the conveyor belt. It's burned in this big furnace. So it's releasing that energy by burning it. And water is pumped in through the furnace where the coal is being burned. So it's like this big boiler. And then it comes in cold. The heat gets transferred, it speeds up, it becomes steam, and then the steam pushes these turbines rotate, the steam cools and then condenses back to go through the system or to be returned back into the river. And then the turbine creates energy through generator, and then that gets transmitted to transmission lines and sent out to people, consumers. So that's how coal turns into electricity that we use. That's how we use coal when we're talking about using a fossil fuel, how we actually use it in our day-to-day lives. Here is a diagram, or sorry, an image of a coal factory where you can see, because right when you're burning coal, you're creating that, not just creating steam, but through the boiler, you are creating exhaust and particles you're releasing to the air because you're burning the coal. So now you can do the check your understanding questions on page 104, questions 1 and 2. Now looking at crude oil and natural gas. Crude oil comes out of the ground as a yellowish black liquid. Natural gas is normally colorless and odorless. They are fossil fuels that are drilled from underground areas called reservoirs or traps found either on land or offshore deep under the seafloor. So here are 2 places where they're drilling for either crude oil or natural gas. So these are big drills that are on land that, again, think about this fence is sort of a reasonable fence, like probably 6 feet high. So you can think about how large these drills are going into the ground to tap in, or this ship, this offshore plant that is drilling under the water. Again, it's hard to have any reference point, but this is just huge. So after they are removed from the ground, crude oil and natural gas are transported to refineries. A refinery is an industrial plant that heats oil and gas to sort, split, and reassemble the various hydrocarbon molecules so they can be made into different products. Crude oil can be made into diesel fuel, jet fuel, and gasoline. Natural gas is an energy source for electricity, steam heat production, industry, and domestic uses like furnace fuel. All right, so then nuclear power is another non-renewable energy source. Nuclear energy is the energy in the nucleus or central core of an atom. I think way back we talked about nucleuses and atoms early on. So nuclear energy is the energy inside of those little atoms. It can be released through nuclear fusion or nuclear fission. These are words that sound very similar but are slightly different. So how are they different? So fission doesn't happen naturally. This is something that we as humans have to force to happen. So it happens when we bombard a nucleus with neurons which target a chain reaction. So this is like happening like super small, right? Atoms are tiny. So we shoot a bunch of neutrons at a nucleus, and it breaks things apart and then continues to hit other things and breaks things apart. So it occurs in nuclear power plants where it's controlled, and also in nuclear bombs where it's uncontrolled. Uranium-235 and plutonium-2 39 are the only fissionable elements. So the only things that we have learned how to shoot neutrons at the nucleus and break apart to create energy. You can see in this diagram where this little neutron, we're shooting at this nucleus and we break it up, and that process of breaking up releases this burst of energy. It produces a large amount of energy. So this little energy that looks here is a large amount of energy, but it also produces waste when we're doing fission. Fusion occurs naturally on stars and the sun. And in the sun, it uses hydrogen to form helium. What's happening is that things get fused, pushed together, and the energy for that process of the things coming together creates energy that can be used when we're creating a new element because two things are sticking together. It happens at 15 million degrees Celsius in order for it to occur. So this is why it happens in the sun. And it's not a practical source of energy because the amount of energy needed to achieve that high temperature is too much. So we'd have to put in too much energy in order to create that energy that we would get out. It does produce a large amount of energy and it does produce waste, but it's just not practical because we can't replicate it because we just can't make things that are so hot that can function on the Earth. So nuclear power plants primarily use uranium-235 as the fuel to make energy through fission. This is because the atoms in U-235 are easy to split apart. Uranium is a common metal that is found in most rocks. However, it is non-renewable, and uranium-235 is quite rare. It makes up only about 0.7% of the naturally occurring uranium on Earth. So now we're going to watch a video that shows how nuclear power actually works, not just how fission works, but how then we use that to and use it in our day-to-day lives.
Ontario Power Generation's nuclear stations are, in essence, factories that convert the energy of the atom into a flow of electrons, or what's commonly called electricity. The electricity that helps power the province. Nuclear, hydroelectric, and thermal generating stations have many similarities in the way they generate electricity. Where they differ is their fuel source. OPG's nuclear stations use naturally occurring uranium that's processed into little ceramic pellets that pack a whole lot of energy. Just 8 will power an average house for 1 year. The fuel pellets are sealed into metal tubes, which are then welded together to form a fuel bundle. And the fuel bundles are then inserted into a large tank called a calandria, which is the heart of a nuclear reactor. Nuclear generating stations split the uranium atoms in the fuel in a process called fission, and the result is the release of a tremendous amount of heat. To unlock the heat energy in the uranium, you need what's called a moderator. In CANDU reactors, a special type of water, called heavy water, is used as the moderator. Heavy water is 10% heavier than ordinary water because it contains a higher than normal proportion of deuterium, which is a form of hydrogen. The heavy water surrounds the fuel bundles and slows down tiny particles called neutrons, so they're more likely to hit and split the uranium atoms. A chain reaction of atom splitting assures there is a constant source of energy to heat the heavy water. The heavy water is circulated through the reactor in a closed system, delivering the heat to a set of boilers where it turns ordinary water to high-pressure steam. The high-pressure steam, made from ordinary water, is transported through pipes to a large turbine, where it pushes the blades and turns the shaft connected to a large rotor in the generator, causing the rotor to spin. The spinning rotor is a large electromagnet that produces a rotating magnetic field. This field moves across coils of copper wire, called a stator, producing electricity that is sent across transmission lines to homes and businesses throughout the province. OPG's nuclear generating stations have sophisticated safety systems to control, cool, and contain the process each step of the way, generating electricity safely and virtually free of all smog and greenhouse gas emissions.
All right, so that
Video showed us not only how fission happens, but then also shows how the generator, the process through heating that water again and creates steam that then transfers into electricity, which is the same with coal, except coal is the source of creating that heat. So now you answer the questions on 105. Questions 1 and 2 are the key questions there. All right, so then let's talk about renewable sources of energy. So hydroelectric power. Hydroelectricity is electricity that is generated from falling or flowing water. So we're still getting the same product. We're getting electricity, which is the same as what we got from nuclear energy and from coal energy, but we're getting it through the falling or flowing of water. Hydroelectric power plants or hydropower plants use turbines like coal, natural gas, and nuclear power plants, but they use the force of moving water to turn the turbines that drive generators to produce electricity. The best way to build these plants are along fast-moving rivers or streams, in mountainous areas, and in areas with consistent rainfall. Canada's geography is well suited for hydropower. It is the source of most electricity used by Canadians. This is why most people talk about hydro as their energy source, like their hydro bill or hydro in their house. We're talking about electricity that is generated through hydroelectricity, through movement of water. Here is an image of a dam where you can see we're harnessing. We can't see all of the stuff, but we can see the water is calm at the top and then it falls down, and that energy that is for that movement is being trapped and transferred to create electricity through machinery that we can't see in this picture. Here is another image. You can see another dam that is creating hydroelectricity. All right, so then solar power, what's that? Solar power is power generated by harnessing the energy of the rays from the sun. It can be used to heat houses and water and also to generate electricity. Solar power is generated through several different methods: photovoltaic, active solar, passive solar, and concentrating solar. So let's just look a little bit more of what those different things are. So photovoltaic cells. So this is between photo, which means light, and voltaic, which means electricity. So PV cells for short are grouped together in panels, and they're made out of semiconductive materials such as silicon and glass. When light strikes these cells, so remember light energy hits these cells, the electric current is produced and then transferred through a transmitter. So the light energy hits the glass and the cells that then that gets transferred through to create electricity. So these are, when we look like at a solar panel field, these are the types of panels that are in the field. Then we have active solar tech. So these are used as collectors such as mirrors and metal plates to capture solar energy to heat air or water. Active solar energy is often used for space heating and for water heating. So here is an image where you can see solar panels on top of a home, and those panels are transferring that heat. They are moving it to a boiler that is heating water, and that is potentially heating the air around it as well. Then passive solar technology uses the basic building materials like windows and insulation to control the amount of solar energy that is absorbed or lost in a building. So here is a home that has passive solar tech. So it's just how it's built to make the best of capturing that heat and light energy from the sun. So it has insulated walls and roofs, and the windows face mostly the equator. So in the northern hemisphere, that means that we're facing south, because that's where we get most of our light. The sun is on to the south of us during most of our day while we're in the northern hemisphere. But the summer sun, the way that the roof is built is that it's going to hit. It's for most of the day, it's going to hit the roof because the sun is higher. But in the winter, it's at a lower, the sun's at a lower angle. And so it's going to hit the windows and come in. The warmth, the heat from the sun is going to come into the house. The same with shading. The trees are set up in a way to block the sun in the summer. And you have thermal mass flooring or things that absorb that heat as it comes in. Then we have concentrating solar panel, and this uses mirrors arranged in towers, troughs, or dishes to concentrate solar energy to drive generators or engines to generate electricity. So here again, you can see all of these mirrors are towards the sun and then reflecting and hitting back to these towers where the reflector captures that light and then transmits it to a generator to create electricity. All right, and then we have wind power. So wind power uses the kinetic energy or the energy of motion in moving air. It's mainly used to generate electricity or as a mechanical power to grind grain or pump water. Turbines are used to capture the power of the wind. Large turbines are often grouped together in wind farms that provide power to an electrical grid that services homes and businesses. Wind turbines blades which spin a shaft that connects to an electric generator that makes electricity. So that's how wind turbine works, is that it's like many things. Instead of heat and steam moving a generator or a shaft, a turbine, the wind actually just moves the turbine to create energy in the generator. And they come in different sizes, but generally there's two types. So there's the horizontal axis. So horizontal is like lying flat. Horizontal axis turbines look like windmills that can stand about 20 stories or 217 feet tall, with 3 blades that can measure longer than a football field. These are the most common type used today. And here you can see the horizontal axis. So the turbine is here inside of the hub of the blades, and then the blades are out and they get pushed around, and then that horizontal axis creates the generator, creates the electricity inside, and then is transmitted out. So these you can see in our, not locally, but there are some wind fields in Northern Ontario. Then vertical axis wind power. So here vertical is like up and down, and they have 2 blades that go from top to bottom. They look kind of like large egg beaters. So here you can see in the image, the axis, here's the vertical part. And so the blades are going to rotate around and create movement that is then transmitted in this vertical axis, this middle column. Both types of turbines can be found both on land or on water. Here are 2 wind fields where you can see this is a horizontal axis. And here's a vertical axis to just see my other examples were on land. And here you can see some that are on water, on big water. So that was wind power. Now let's look at tidal power. So a tide is the alternate rising and falling of the ocean on a shore or coastline caused by the gravitational pull of the moon and sun and the rotation of the earth. So that's the basics of what a tide is the moving of water in big land bodies of water. So tides also can be used to generate electricity. A common form of tidal power involves building a large dam called a barrage across a river or outcropping of land. The barrage funnels water into a generating plant and through a large turbine as it flows in and out with the tide. Instead of barrages, tidal turbines can also be used to generate electricity. Tidal turbines take advantage of the natural tidal flows. They can be anchored to the ocean floor or floated offshore. So here you can see the 2 different ways. So here this is looks like a dam, but it's just capturing, it's flat, nothing's falling. Nothing's being stopped, but just that movement of the water going in and out is creating electricity. Or here, they look similar to the horizontal axis wind turbines, but it's under the water. Again, these blades are being rotated by the movement of the water back and forth. So the Annapolis tidal power plant in Nova Scotia is one of 3 in the world, but it closed in 2019 due to fish mortality and equipment failure. So this is a picture of that one in Nova Scotia, but again, it is no longer running. So there's very few tidal power plants in the world. And then we have geothermal power. So geothermal energy is heat that is generated within Earth's core, so from inside the Earth. The temperatures hotter than the sun's surface are produced deep inside the Earth because of the slow decay of radioactive particles. Large areas of geothermal energy called geothermal reservoirs are found mostly deep underground. So here you can see we have our crust of the Earth and then deep, deep, deep underground. So this is about 4 kilometers deep underground is where the geothermal reservoir is. And that is, we pump things in to crack it and to then release it so that it then gets sucked up and can then exchange that heat. So just the same way as that it's going to create a turbine and generator is going to use the heat from deep in the Earth's core to create electricity. And then finally, we have biomass energy. Biomass is organic plant material and animal waste, and it contains energy stored from the sun, right, that we've used to grow. Through photosynthesis, plants convert the sun's energy into chemical energy that they store in their leaves and stems. The chemical energy is passed on to the animals and people that eat them. So some examples are wood and wood products like bark and sawdust, agricultural crop leftovers, animal manure and food processing wastes, organic portions of multiple municipal solid wastes. So there are 3 main ways to convert biomass to energy. Biomass can be burned to create heat. This can be used to create steam to drive turbines generating electricity or to also to heat buildings. Biomass can be heated but not burned to break down into gases, liquids, and solids. Then these can be processed to make fuels such as methane. And also biomass can be fermented or broken down by microorganisms like yeast and bacteria to create biofuels such as ethanol. Biofuels are mainly used in vehicles but can be used to power other engines and fuel cells. And here is a biomass power plant. Looks kind of like the same. Right, and I forgot hydrogen fuel cells. The hydrogen fuel cell is a relatively new energy source. It can be thought of as a cross between an electrochemical cell, which we use in flashlights and things like that, and a generator. Electrical chemical cells convert stored energy, chemical energy into electrical energy. However, unlike regular cells and batteries, fuel cells do not wear out over time. Hydrogen and oxygen power fuel cells to make electricity. The only byproduct is water. So hydrogen fuel cells can be used to power electric vehicles, to provide emergency power in remote areas or hospitals, provide portable sources of energy for technology, power space vehicles, electrical systems. So those are all the different renewable and non-renewable energy sources. I have realized that I didn't actually ever define renewable and non-renewable. I feel like we have talked about this before, but it's good to define it as well. So non-renewable energy sources are fossil fuels that we depend on. Most of our energy is through fossil fuels, and but they are depleting because they are non-renewable. We cannot create them again. We've talked about how it takes thousands upon thousands of years for fossil fuels to be created. And so they are non-renewable. When we use them up, they're gone. And so this is coal, crude oil, and natural gas, and nuclear power are all non-renewable energy sources. They can create a lot of energy, but once we use them up, they are all gone. We can't get any more. Then renewable energy sources, there are a whole bunch, and they create a certain amount of energy. So just a reminder of what they are. Hydroelectric, solar, photovoltaic, sorry, I want to put an R in there. Active, passive, and concentrating are all solar types. We have wind, which we have a horizontal axis and a vertical axis types of turbines. Tidal, geothermal, biomass, and hydrogen fuel cells. So all of these as renewable energy sources are things that we don't use up. So we use the type of energy that we use is transferred to become electricity. So it's either the heat or the movement. So it's that kinetic energy that we can then transfer through turbines to electric energy. Or it's heat energy that we do the same thing. So hydroelectric, wind, geothermal are all, no, sorry, hydroelectric, wind, and tidal are all about the movement of things. And then solar, geothermal, biomass, and are all about heat and using heat energy to create electricity. And then hydrogen fuel cells use chemical energy to create electricity. So electricity is the way that we use our energy, but these are all different ways that we don't use up the movement, the heat, the chemical energy doesn't get used up to never be used again. With time, because it's renewable, it means that it's constant. It just happens. We don't use up the wind when we use that motion, we use the movement to create the energy, opposed to something that we use up that can never be used again or that disappears. So hopefully you're feeling comfortable to explain why coal, crude oil, natural gas, and nuclear power are all non-renewable energy sources, and then also we talked about how they all are generated, where they come from. And you can explain how hydroelectric, solar, wind, tidal, geothermal, biomass, and hydrogen fuel cells are all create renewable energy. Now you can do the review questions on page 109, questions 1 through 7. So this is a smaller list. And as always, if you have any questions, please reach out and contact us. If you want to talk about the actual lesson, connect with me, Bronwyn. You can call me either at our main number, 807-737-1488, which is our local number, or our toll-free number at 1-800-667-3703. And my extension to talk with me is 2209. You can email me at bronwyn.slate@nnec.on.ca. Remember, all of our lessons continue to be recorded and uploaded to YouTube at my channel at bslate Wahsa. So you can connect with me and go there to watch all of the replays, as well as watch all of the videos supplementary videos that are that we watch in class. So you can watch them from the original sources and access that information to find out more about it. And then the change is that John is now the course marker. So he's the one who's actually evaluating you. So if you want to connect with him and ask him questions about his thoughts and opinions about things, please reach out to John. His email address is jstradiotto@nnec.on.ca. Again, you can call him at the same two numbers in terms of our local number and our long distance or our toll-free number, but his extension is 2210 if you want to go directly to him. His office hours are 8:30 to 3:30 Monday through Friday, but he takes lunch from 12:30 to 1:30, so isn't available at that time if you are trying to connect directly with him. Thank you so much for joining me today. I hope you learned something and this all makes sense to you. Look forward to having you here with me again, and Mwich.